Assalamualaikum guys. Today we will start with family number 2, that is alkenes. Its name ends with ene. Family name is ene, and it is also known as hydrocarbons, as it only contains carbon and hydrogen in it, like alkanes. And its general formula is CnH2n, and its structures contain CC bonds, CH bonds, except there is a double bond between the carbon atoms, C double bond C. Now, name of alkanes, this is the methane. Molecular formula, its molecular formula is CH2, as it's CnH2n. So double the number of carbon atoms. The double the number of carbon atoms. There are hydrogen atoms. So CH2, C1H2, double the number. And since methane structural formula doesn't exist, because methane doesn't exist as a compound in this universe due to its incomplete bonding. It is the empirical formula of all other alkene members because methane does not exist as a compound in this universe because of its incomplete bonding. Like ethene, here we come C2H4, eth for 2, so C2H4, double the number, so here C2H4. If we want to draw the structure of methane, we can't draw it actually like this. And as we studied in the previous video, that carbon makes four bonds overall, and hydrogen only makes one, because hydrogen only has one free valence electrons, whereas carbon has four free valence electrons. So carbon makes four and hydrogen makes one. So if we want to draw the structure of methane, it is like this. So carbon, it has free valence electrons. It has the ability to form more covalent bonds, so it is not a complete structure. So methane doesn't exist as a compound in this universe. Ethene does exist because there is complete bonding. There is a double bond between CC, double bond between carbon atoms, and so here H, here H, here H, here H, so C2H4. Now propene C3 double C3H6, so here is the double bond on the first carbon. Here it's also on the first carbon, so here it is also on the first carbon, C double bond C, and then this structure. Then butene C4H8, double bond on the first carbon, so C4H8. Pentene C5H10, double bond on the first carbon. Here's the structure. Hexene C6H12, here's the structure. Heptene C7H14, here is the structure. Octene C8H16, this is the structure. And here there is hydrogen atoms attached to these carbon atoms. And nonene C9H18, decene C10H20, and here is the structure. You must also draw it on your note copy by yourself. Now after alkene, in which there was CnH2n, the general formula of the family, we are coming to alkyl group. This is not a family of organic compound, it is a group. We are studying it separately. Alkyl group, this is not a family of organic compound, it is just an organic group. Alkyl group doesn't exist alone due to its incomplete bonding. Its end name is Yl. How is alkyl group formed? It is formed by subtracting one hydrogen atom from the alkane. Like its general formula, alkyl's general formula is CnH2n plus 1, alkyl group, and alkane's general formula was CnH2n plus 2. So if we subtract one hydrogen atom from this, we will get CnH2n plus 1, meaning that how we can form alkyl group, we can form it by subtracting one hydrogen atom from the alkane. It contains all CC and all CH bonds. We can't say it's hydrocarbon because it's incomplete bonding. So names of alkyl groups are methyl, first methyl, Molecular formula CH3, structure formula you can see it here that it's incomplete bonding. This carbon is left, this single covalent bond of carbon is left, it's incomplete, it's not bonded, so it's an incomplete bonding. Ethyl C2H5, it's also incomplete bonding. Propyl C3H7, you can see here incomplete bonding. So and all these there is incomplete bonding. Butyl C4H9, C4 4 2s are 8 plus 1, so H9, C4H9 butyl. And now pentyl C5H11, here is the structure, incomplete bonding in the end, you can see. Hexyl C6H13, structure, incomplete bonding in the end. Heptyl C7H15, octyl C8H17, nonyl C9H19, decyl C10H21, and here's the structure, incomplete bonding in the end. There is one single covalent bond left for this carbon atom to be bonded, so it's incomplete bonding. Now coming to family number 3. This wasn't a family, alkyl group, remember, this was a group. This was not an organic family. The first organic family was alkane, the second was alkane, and now coming to third family, organic family, that is alkanols. This is now a family. Its family name is anol, ends with anol, also known as alcohols. Alkanols, also known as alcohols. How are alkanols formed? They are formed by attaching this OH group with this alkyl group. You know that there was this bond left, so if we attach this OH group in the end here, this OH group, we will get an alkanol, because carbon will form a single covalent bond with O, which further forms a single covalent bond with hydrogen. So oxygen, since oxygen has 2 free valence electrons, so it forms 2 single covalent bonds, one with hydrogen and one with carbon, and this hydrogen has 1 free valence electron and it forms 1 single covalent bonds with oxygen. And carbon, it also forms 4 single covalent bonds when it is attached to OH group. So now it's a complete bonding, so it's a family, organic family, that is known as alkanols. Note, functional group, alkanols functional group, what is a functional group actually? Functional group, it is a group of atoms that give special properties to an organic compound. Here the functional group is OH because it gives a special property to alkanols. It is special in it. It is not found in other organic families. It is found in alkanols. General formula of alkanols is CnH2n plus 1 and then OH in the end. This all is alkyl group and then attach OH in the end, so it forms an alkanol. Structures, there is all CC, all CH, and then there is COH bond in the end. Like this name of alkanols, first methanol, CN, C1 1 into 2 plus 1 3, CH3, and then OH in the end. Its molecular formula. Structural formula is CH3 and then attach OH in the end with this carbon atom. And then ethanol C2H5OH, attach OH in the end. Propanol C3H7OH, this is the structure. And then butanol C4H9OH, structure. Pentanol C5H11OH, structure. Hexanol C6H13OH, heptanol C7H15OH. These are the structures. The rest are, which ones are left? Octanol, nonanol, and decanol are left. That is a task for you to draw their to write the molecular formula and draw their structural formula. That is your task. Now we are done with our third intro of our third organic family as well. Now coming to our fourth organic family, that is alkynic acids. Its family name is anoic acids. Anoic acids, in that it is also known as carboxylic acids. Alkynic acids also known as carboxylic acids. How are alkynic acids formed? They are formed by attaching COOH group to alkyl group. What we studied on the previous page was that if we attach OH group only with the alkyl group, we will get an alkanol. And now we are studying that if we attach a COOH group with this alkyl group, we will get alkynic acids. Now, what is this COOH? This is the functional group of alkynic acids. Like for alkanols, the functional group was OH. Here for here for alkynic acid, COOH is the functional group for alkynic acids. So it discriminates, it differentiates between the two organic families, that is alkanols and alkynic acids. So general formula for alkynic acids is CnH2n plus 1. This is the alkyl group, and then it has COOH. So overall CnH2n plus 1 COOH. Structural formula all CC, all CH, and here all CO. This is COOH. This is COOH. COOH. Now name of alkynic acids. Name of alkynic acids: methanoic acid. Molecular formula HCOOH, and then structure formula here HC, and then COOH. How we draw it? We draw it double bonds, carbon double bond with O, and then carbon single bond with this O, and then this O single bonds with H. So this oxygen also completes its its bonding, and this oxygen also completes, as it forms two single covalent bonds. It also forms two single covalent bonds, and carbon overall forms one here, two here, one here. So overall four single covalent bonds. So it's a complete bonding. So structure formula for methanoic acid is this one: methanoic acid CH3COOH. Here's the structure formula. Propanoic acids C2H5COOH, and this is the structure. Now this butanoic acid, its molecular formula is C3H7COOH. Here its structure: pentanoic acid C4H9COOH. Structure: hexanoic acid C5H11COOH. Heptanoic acid C6H13COOH. Octanoic acid C7H15COOH. Nanoic acid C8H17COOH, and decanoic acid C9H19COOH, and here's the structure: COOH in the end. Now hydrocarbons. What are hydrocarbons? Hydrocarbons are those organic compounds which contain carbon and hydrogen only, for example alkanes and alkenes. So the families we have studied so far: number 1 alkanes, number 2 alkenes, number 3 alkanols, and number 4 alkynic acids. We first studied that hydrocarbons. What are hydrocarbons? Those compounds which only contain carbon and hydrogen. So only we noticed that only alkanes and alkenes contain carbon and hydrogen, not any other element, whereas alkanols and alkynic acids contain oxygen in them. So it means that only alkane and alkenes are hydrocarbons. Now there are actually two types of hydrocarbons: one saturated hydrocarbons, the other one unsaturated hydrocarbons. Number 1 saturated hydrocarbons are those hydrocarbons in which there is a single covalent bond between carbon atoms, and that is in alkanes, whereas the unsaturated hydrocarbons are those hydrocarbons in which there is a double covalent bond between carbon atoms, and that we know is alkenes. Now coming to homologous series. What is homologous series? It is the series of organic compounds in which each successive member differs from the previous by a CH2 group, and this happens in all alkanes, alkenes, alkanols, alkynic acids. So alkane is a separate homologous series, alkenes separate homologous series, alkanols separate homologous series, and alkynic acids also separate homologous series. They are, because if we take this butanoic acid, here C3H7COOH, and here C4H9COOH. This is the successive member of this. So if we differentiate between them, we will find that C4C3, one carbon difference. Carbon difference, how many there are? C3 4 carbon atoms, and there are C4 5 carbon atoms. So there is a 1 carbon atom difference. And how many hydrogen atoms? H7 8 hydrogen atoms, H9 10. So 2 hydrogen atoms difference, and then O2 O2, so CH2. So if we take any alkanes, alkenes, alkanols, alkynic acids, you can check it. We will found that each successive member differs from the previous by a CH2 group. So what is the properties of homologous series? The property number one is all members in a family behave similarly in chemical reactions. Like all alkanes will behave similarly, all alkenes will behave similarly, all alkanols and all alkynic acids. Property number two, there is a gradual change in the physical properties down the homologous series. Like explanation, in alkanes and alkenes, if we take only alkanes and alkenes, from C carbon number 1 to carbon number 4, 1 carbon atom to 4 carbon atoms, they all are gases. And then from 5 carbon atoms to 25 carbon atoms, they all are liquids. In which from C5 to C16 they are thin liquids, and from C17 to C25 they are thick liquids. And then if we take C26 and onwards, they all are solids. So what happens in alkanes and alkenes? As the carbon number increases, the state changes from gases to liquids and then to solids. So the state changes. In alkanols, what happens? All alkanols are liquid at room temperature. Alkynic acids, all alkynic acids are aqueous. Now, what is our property number 3? It is that down the homologous series, melting point and boiling point increases. Why it increases? Because down the series, intermolecular forces of attraction keeps increasing, so the energy needed to overcome these attractions keeps increasing. Why this intermolecular force of attraction keeps increasing? Because the state changes from gases to liquids and then to solids. As you know that gases are the intermolecular forces of attraction between gases are easy to break than liquids, which are which are then further easier to break than solids. So solids require the most energy required to overcome these intermolecular forces of attraction. So as a result, melting point and boiling point increases down the homologous series. Property number 4, down the homologous series, viscosity of liquid increases. We studied that from C5 to C16 it is thin liquids, and C17 to C25 thick liquids, so viscosity increases from thin to thick. Viscosity is actually the density. Property number 5, down the homologous series, the more relative molecular mass of the compounds increases regularly. We know that the number of carbon atoms increases, due to which the number of hydrogen atom increases. So as a result, if we calculate the molecular formula, that is molecular formula of the organic compounds, so it increases down the homologous series. So this is it for today. Review the video again so that you understand the concepts completely, and in our next video we will be starting with isomers. That is a very important part of the organic chemistry of all levels. Thank you.